Okay, great. Recordings are starting. Let's again, just for the guys joining, if you want to join the WhatsApp group and you're not on the WhatsApp group yet, send me a WhatsApp on 083-790-8387. What you can also do, I'm going to quickly just share the link to the WhatsApp. Let me just share the link to the WhatsApp also in the chat, so that if you want to join via the WhatsApp link in the chat, you can do that as well. So that is again just my WhatsApp details, so that you can be on the DSC1520 WhatsApp group. Okay, and then today we're starting with differentiation. We have skipped a chapter, but if we have time today, we'll go back to chapter 4 as well, just to see how far we can get with that. But if not, we will catch up with the rest of the chapters that we have skipped. Okay. For your next assignment, you need to be able to differentiation, and that's why we're doing it today. So there's two things that we're going to focus on in the differentiation. The one is how to calculate the slope of the curve, and how you're going to use that in your differentiation. And then we're going to focus also on the differentiation rules. So specific rules that you can apply in the differentiation questions. Okay, so I think the most important part of working out the slope, so what that gives us is that the slope that we're gonna calculate is gonna be the slope of the line that touches the what is it, hyperbole. So what we will do is, if there is points on your curve, so if there's a point A and B, we will be able to work out the slope of that touch point. Here we've worked out on this graph, the point is going through B, so that was for one touch point that we worked out. We can work out a few on the graph as well. So when we work out that slope, it will be the touch point to that graph. So the other thing that I think it is important is, so when, and say, remember when we looked at quadratic equations, so let's say this equation was something like this. Okay, so it's going up, that's why it's positive. It's somewhere up there, so I just made the y cut off a bit higher as well. So let's say this was this equation's formula. Then when we need to differentiate, and we'll go through all those steps now, but when we differentiate this formula, we're gonna get the line that touches the hyperbole. So we're gonna get the line that touches this quadratic equation. Okay, so let me quickly differentiate it. So let's just say I differentiate it. I'll go through all the rules how we work it out, but what normally happens is that 2 goes in front. Then what happens with this is that it's, let me just change cables and it's still, so I need to try to fix this again with something else. So then it becomes 2 minus 1. And again, I'll show you now in all the rules as well. Then here is actually a hidden 1. So when we take that to the front, 3 times 1 is 3. And then it's x and 1 minus 1. Okay, and then if we just make that simpler, we will get 2x, 2 minus 1 is 1. So we can have a 1 there or we can leave it out. And then we have 3. Remember from the work you guys did in the first chapter nearly, x to the power of 0 is equal to 1. So anything to the power of 0 is equal to 1. So basically we're sitting here with 3 times 1. So your differentiated formula would have been 2x plus 3. And this would probably then be the one going through there. You have your 3 there, and your x will be somewhere on this line. So whenever you differentiate your quadratic equation, you get the touch line of that quadratic equation. And I think that is also important when, not for chapter 5, but when we go into chapter 6, we talk about nearly all of the things that we've done in chapter 3, I think, when we talk about the demand and supply curves. In chapter 6, we will start talking about marginal. So when we get to the marginal curves, and the marginal curves is basically every time that you differentiate a function, you get a marginal curve. But that's for chapter 6. Today we're only going into the theory of differentiation. Okay, so this is again just showing you how they calculate it and how they get to the from a quadratic function, and you differentiate it to get to your simplified function. You guys don't need to know really all the maths behind it, so you don't need to go now into your first principles and those kind of things. You don't need to know the limit rules or anything like that, or need to know how to get from first principles. That's not for you guys. You just need to know that what we do when we differentiate, and this was again, so if you differentiate the x to the power of 2, the differentiation rules state that, so that will become 2 minus 1. We take the 2 to the front, and that will be your differentiated equation. So if it was x to the power of 2, when we differentiate it, we will get 2x. Okay, so please don't go and study all of the limit rules and those kind of things, because you don't need to. If you really want to know the background of it, Google a YouTube short video on limits and just for background, but please don't go into the maths of this. It is really time consuming, and again, you don't need to. So they're not gonna, and they can't. So if, and this is what I'm nearly talking about. So again, you guys are writing where it is multiple choice. So when you're writing multiple choice, there is just no ways they can ask something like this. So please, again, don't worry too much about the limit rules. Again, YouTube a short clip, and then you can use that just for background. But please don't go and study this. Okay, it really is not needed. Okay, for this guys that joined, please, this on the chat, I've included a link to the WhatsApp group, so please join the WhatsApp group. Also, if you can't join it from the chat, my number that you can send a WhatsApp to is 083 790 8387. So we're going through chapter 5. Hopefully we can also go through chapter 4 a bit, but let's see how far we get. Okay, so please, again, don't stress too much about the maths behind differentiation. The important thing that we're going to go through is that you know your differentiation rules. And again, I will give you guys a summary, a few summary pages of the nearly the formulas and things that you need to know for this subject. You don't need to go and study the differentiation rules. As we go along now, we will make notes. You can have those, you can write even those differentiation rules down for yourself. So when you write exam, it is available. You don't need to go and really remember the rule. I think much more important is how to use them. Okay, so that part that I showed you how to differentiate that easy formula, if I can put it that way. So that is the first rule that we're going to cover, and that is the power rule. So the power rule basically says that when we differentiate, we take whatever you had, so x to the power of whatever there was, that you take up to the front, and then that power that you had, you subtract 1. So if we had something like x to the power of 7, this, if we differentiate this, so if we say, well, we differentiate dy dx, remember another way I wrote it was nearly that. So there is a few ways that you can write it. Another way to write it is that way. So that is just a way also to write it. So with that rule, what we're basically doing is take that to the front, and then what the rule says is 7 minus 1. So our answer would have been 7x to the power of 6. That would have been your differentiation of x to the power of 7. What they can also do is to ask you, but differentiate that a second time. Then it will be a sign like that, where it just gives you another differentiation. So then if we differentiate, we need to say, okay, what is 7 times 6? That's 42. And then it will become 6 minus 1. So 42 to the power of x to the power of 5. Okay, so that is nearly for the power rule that it's very simple that we're going to do. We're going to go through a few examples because you can now get a formula like this, where you need to use the power rule a few times. I think I've got one of them in here, so we are going to do it. But you can get a long formula like that, and you probably will get something like that in your assignment, because what that does is, for this one, nearly test that you know how to do it for all of them. So we will go through an example like that. Here is an example of nearly what I now did with x to the power of 7. Exactly the same when you look at how they did it with x to the power of 5. You bring the 5 in front, and you say x5 minus 1, and that is your final answer. So again, if you write it like that, or you write it like that, exactly the same. So the reason why I show you both is just because in the exam they can ask you, or they can ask you, work out this, so that you don't now say, ooh, what is that again? So they can use the two signs, or the way that they show you how to differentiate in a few ways. So that is just basically two of the ways that they can show it to you. Okay, so let's go into this long one. I just want to quickly, let's insert block here so that we will work it out here, and then you will get, I'll reveal the answer just again. I just want to make sure. So what they showed us here, and I think that is just very important, but we will get to it as well, is that when we get to something like that, where did my draw go? We will see what happens when it becomes x to the power of 0. So we will quickly show that to you guys as well. Okay, so let's look at this one. So if we differentiate this, what we get is, okay, so let's differentiate that first one. We've got x, take the 4 in front, so that nearly becomes the first thing I'll always do. 4 minus 1 will be the next step. Okay, so then the next the next factor or the next term that we look at, 2 to the power or 2x to the power of 3. So bring the 3 in front. 3 times 2 is 6. X 3 minus 1. Then 5. 2 goes to the front. 5 times 2 is 10. X to the power 2 minus 1. And let's just go on here. 3. So you can also basically show that as x to the power of 1. So 3 times 1 is 3. X then 1 minus 1 plus 100. 100, there is no x to it, so any constant will fall away. So if we differentiate a constant like 100, like 5, like 7, it all becomes 0. Okay, so if we differentiate any number, it will fall away and become 0. Okay, so now we sit with that new line. So 4x to the power of 4 minus 1 is 4x to the power of 3. 6x to the power of 2. Minus 10 stays, so it stays negative 10. X to the power of 2 minus 1 is x to the power of 1, which you can also write without the 1. 3x1 minus 1 is 3x to the power of 0. So here we just write it over. Minus 10x, let's write it as it should be, 10x. X to the power of 0 is equal to 1. So remember, even if we add 5 to the power of 0, it's equal to 1. So anything to the power of 0 is 1. So what we have in this one is 3 times 1. So we'll end up with just the constant of 3. Okay, so that is if we needed to do the first differentiation. Let's take quickly that. So let's just take that away, and you can see how it was done as well. I just want to do an extra step. So if we then said, but let's do the second differentiation on this. The second differentiation would just be, okay, let's follow the same process. 3 times 4 is 12. X 3 minus 1 is 2. 6 times 2 is 12. X will be 2 minus 1. So it will be to the power of 1, which is in any case, we can just take away. So it becomes 12x. And then we have the minus 10x. So again, x will be 1 minus 1, which will go to x0. So if we needed to do second differentiation, our answer would have been 12x to the power of 2 plus 12x minus 10. Yes, Devon.
Morning, Jean. How you doing?
Good, and you?
Good, good. I nearly said lekker, but allow me to say that. Listen, my answer, can I stop at 4x by 3
Yes.
and 6 x by 2? Can I stop there and not take it further?
No, you need to do the whole you
So I
need,
still have to continue with the differentiation.
yeah, you need
Yeah.
to, yeah,
Okay. All right. Okay. All right. Let me
yeah,
follow on, because how you did it, I enjoy
yes.
how you simplified it. I even wrote it down. However, I fell off the chair when you went further with that. But let me continue to listen. Thank you.
Okay, so why did you stop?
No, I got interrupted with the fact that I stopped there and I was like, okay, that's the answer. But then as you moved along, I got lost, but then I will catch up with it on the video again later. It's okay.
Okay.
All
Okay,
right.
but we are going to go through lots of examples today. So don't worry, I'll show you again how everything works in one of the next examples as well.
Perfect. All right.
Cool.
Thank you. I'm not raising my hand. I'm just trying to
Okay.
think.
Perfect. Okay, so let's go into another one. Um, so you guys will also um see this, and it's still part of the power rule. So where did we say it's still part of a power rule? What we are, and here is examples. So let me put in a new slide, and then we can just rather, I'm gonna write down the formula that we need to differentiate, and then we can work through it. So I want to, let me quickly see, not that one. So let me just quickly write it down here for myself, and then I'll write it down on the next page. So I'm gonna look at the 1 over x2, and then I'm gonna do the fourth one as well. Okay, so the first one that we're going to look at is 1 over x to the power of 2. Okay, so we're still going to use the power rule. Okay, so this one, it looks difficult, but I want to first simplify it. I don't like to work with fractions at all, so I want to simplify it. So remember nearly from chapter 2, when we looked at some of the fractions and things like that, what we can do with something that's below the line, we can take it to the top, but then the sign changes. So this answer, or this, if we simplify it back, it means x to the power of -2. So think about it first in the format of, if you had this, 1 over 2 to the power of 2. Okay, so then I would have said, okay, let's change it. And then it would have become 2 to the power of -2. And you can work out on your calculator 1 over 2 to the power of 2. That will be equal to 1 over 4. If you work that out, it will also be 1 over 4. Okay, so that was nearly the rules way at the beginning. If we look at exponents and things that they assumed already that you need to know for this course. So again, now it's simpler to to work with that, because now we can follow the principles if we need to differentiate that. Yes, it's weird to work with a negative number, but we follow exactly the same rules. So the -2 times whatever is in front. So in actual fact, there's a 1 in front, so it becomes -2. X, remember we had the -2 and we will always have said -1. So that exactly stays the same. Now that answer is -2 x to the power of -3. Okay, so now again, as I said last week, let your answers that they give you nearly determine if you need now to change that into a a fraction or not. So if they give you a set of answers that looks like this, please don't change it, because then you won't get in your answer set what you're looking for. But if you see fractions in your answer set, we can change it. And how we change it is easy. We can say, well, that goes to the top, and we knew that x minus 2 was actually x to the power of 2 below the line. So what will happen here is that below the line we will just sit with x to the power of 3. Okay, so still the power rule. We just make it simpler for us to use the power rule. Again, if you've done it under the line only, it becomes very difficult how to work with it under the line. So I really always want to create something that doesn't have fractions in when I work with it, but we can always put it back into a fraction if needed. Okay, so again, power rule. So if it's negative or positive, we use the same principles. We'll take the -2, multiply with whatever is in front, and then we will say, if it was now -2, we will still subtract 1 from it. Okay, and then -2 minus 1 is -3. Okay, so that is one way to work with it. Then the next one is when we have a few of them. So the example of x minus 4 1 over x plus 8 2 over x squared. Okay, again, I'm like, I really don't want to work with fractions, so I'll simplify it a few times. So let's just simplify that by multiplying by the 4. So I haven't taken the fraction away. I'm just the first step, making it easier for me to go to a fraction or leave out the fraction stage. So 8 times 2 gives you 16 x to the power of 2. Okay, so that still is not in the way that I want it, so I need to change it one more time to nearly put it in that format. So I do that, so we'll get x. Remember, there's actually, again, a hidden 1 there, so if I take that to the top, x minus 1, and then if I take this to the top, it becomes x minus 2. And now we can do exactly the same as we did With the previous one, we need to work with the power rule. So 1 goes in front, then it will be x1 minus 1. Minus 1 times minus 4 is actually plus 4, x minus 1 minus 1. So we'll simplify that as well in the next step. Then minus 2 times 16 is actually minus 32. And again, in the next step, we'll simplify that because it's minus 2 minus 1. So again, you can see every time I used the minus 1 because of the power rule. Okay, so it looks again a bit like we say in Afrikaans de mekaar. So there's a lot of things in here that one must keep your head when you're going to calculate it. X to the power of 1 minus 1, so that's x to the power of 0. X to the power of 0 is always equal to 1. So we have for that first one, if we differentiate that one, actually we've got 1. Then we've got 4x to the power of minus 2. So in the next step, that will be 4x or 4 over x2 if we need to simplify it. Okay, so I'm nearly going to show every time if we do a simplification part, that will be our answers to a simplification. Okay, so now on this one, we sit with minus 32 x to the power of minus 3. So again, we can say that is minus 32 over x to the power of 3. Okay, so again, what we've done, depending on how your answer set will look like. So if your answer set in your assignments in exam does not have any fractions, keep it at that second one, because that is then what you will look for. If your answer set has fractions, it will be the last one that we will look at. And what will also in both your assignments and exam, you will not get something that the answer is part or part non-fraction, part fraction. So you will not get something like this as your answer set. Okay, so that they will never do. It will be or the one without the fraction, or all of them will be the one with the fraction. So you won't get in the exam one that's nearly a mixed term, where one is without fractions and for one is with fractions. You will never get that. Okay, so your answer set will always reflect the same things. So please don't worry about that. So if you need to go simplify everything to the last one that has fractions, it will then be that you will do it with all your terms. Okay, so I will share these slides in any case with you so that you can go and test. Let me just make this again fit 100%. Okay, so we've looked now at this one. So there you can also see how they write it into the two formats. And we look now at the last one where again we add that format, but we also have the one with the fractions. Okay, so depending on how they want it, so most times if I write it in the original format with fractions, you will normally have it in your final answer as fractions. If I have written it in this format, you normally will have it in that format in your final answer. But again, it can happen that they want it the other way. Okay, you can go through the first and the third one, and if you struggle, we can chat on the WhatsApp in any case. So you can practice that, and I'll send you guys also some more practice functions, so that you can I'll send you like a previous exam paper or just one of the assignments, and you can look at that as well. Okay, so that was the first rule that we looked at was, and you can see there's there's even more. So let's do this one. Sorry, before we go to the next set of because this is also a important one that we need to know. So let's quickly do that. I think that is nearly there is more that I have given, but that is nearly the one that is again a bit different. And again, it is important just to see how we do it from the start. Okay, so they tell us to differentiate 5x plus 2 over x. Okay, so if it was something that could have easily cancelled, then it's something different. But this one, there's nothing really that we cancel out, but we can write it in a simpler format. So 5x plus 2 over x is the same as to say it is 5x over x plus 2 over x. Okay, and then one can simplify that a bit more, because x goes into x once. So now we sit with 5 plus 2 over x. And now we can use the power rule. So we have seen in some of the previous things, a constant, if you differentiate it, will fall away. So that 5 will disappear. And then we can say, but let's just make it 0 for now. This one, again, I don't like with something to work with a fraction. So let's rewrite it. And now we can see, that one I can at least work with. So it becomes minus 2 x to the power of minus 1 minus 1. And then we can say, well, let's make it, that is our final answer, but let's make it a fraction again. So we can make it a fraction again. And you will see it is exactly the same as what they got there. So by simplifying it a bit, or by rewriting it in its first format nearly, one can then start simplifying it to get to a point that you can differentiate. Then when you differentiate, you can see, but there is a way to change it, and then you can again let the answer set nearly determine if you would go for that first one as answer, the minus 2x to the power of minus 2, or if you go to the simplest format of minus 2 over x to the power of 2. Okay, again, the power rule. So the power rule is the first rule that we are looking at. So let's go into the next one. So let's first have a quick stop, and then you can tell me, is the power rule at least a bit more clear than it was before the session? And you can just do a thumbs up on that if you're happy with it. If it's still a bit confusing, I think after I send this session on to you guys, you can check the session again, and hopefully it does make a bit more sense. Okay, cool. Thanks for the answer in the chat, Emisa. Okay, so let's go to the next one. So the next one that we're looking at is exponential and log functions. And I think what's important here again is that you guys, please again, don't go and study. You need to know how to use it. So don't worry how you got to it or anything like that. We just know if that was your log function and we need to differentiate, the first thing we need to remember when you differentiate the exponential function, it stays exactly the same. Okay, so when we differentiate something that was e to the power of x, it stays the same. There's one thing that does have an impact. So if it was e to the power of 2x, the only thing that will then happen is the use of that 2. So as we've seen with the power rule nearly, the 2 goes in front. But what happens with your exponential, the rest stays exactly the same. Okay, so that's the one where it differs a bit from the power rule, is that if you have something to the power of, if there's a constant, you need to bring it to the front, but then e to whatever it was stays exactly the same. Okay, so again, we'll go through an example quickly. Let me quickly just see what that example one was. 10x or 10 to the power ex plus 5e 3x. Okay, so it was 10 ex plus 5 e to the power of 3x. Okay, so interesting in this one is that you have that. You have that. So what we could have done is just to show how it's being done. So there is always in front of a x or anything. If there's nothing, it's actually a 1. So what is happening in this instance, it's 10 times 1, and then the E stays exactly the same. Then with your second one, it is 3 times the 5, so it's 15. And the E stays the same. Okay. So actually this function is one of the easier ones because okay, some very delays here on my side. Sorry about that. Hopefully it will. I don't know what actually happened now. Oof. Okay. I'm just quickly taking that screen out. I just want to see what. Can you guys still hear me?
Lost you there because
Okay. Sure. Okay. I my my PC just rebooted. Let me just get.
okay.
That was weird.
Yeah, the PowerPoint that you were working on,
Yes,
was it on autosave? Please say yes.
I hope so. It
Oh.
no,
It didn't save anything,
it
but it's
didn't
fine.
save it. Yeah, it will luckily be on the recording.
All right, no problem then.
Oh, but yeah, let me quickly. That was so weird. Um, really don't know how that happened. Just see that. Okay, there was, it might be there's a auto recovered file, so let's just hope. Okay, sorry for this delay. Let me just get. Ah, okay, there is at least a auto corrected file that did some saving, so at least there was. Okay, let me just start sharing again. Okay, so there was at least some of it was saved. Okay, can you guys see the slideshow again? Let's just check. Okay, and we were at this exponential one. I just want to check. So that was the one that the E, so that one didn't now save, but that's fine. On the recording that will be there. Okay, so let's go to the next one, where we need to look at the ln function. So we did the exponential one. Now we're going into the log function. So what happens with the log function is that we, if you look at it, what happens, so if we have ln to the power of x, it will become 1 over x. So if we have something like ln 5x, it will become 1 over 5x. Okay, so that is your ln function that we're working with. Okay, so what they then can do, and we'll get to some of those also in the next few slides, is that we need to look at the second rule now, which is your chain rule. So what happens with a chain rule is, and the easiest to look at that is nearly, you're gonna simplify one of the formula. So you will mostly have two terms that you're working with, and you will transform one of those terms into something to make it easier. But we will definitely go through a few examples now. Let me I just want to get to sort out my second screen quickly. I'll be back in 2 minutes. Okay, so hopefully, ah, lots of troubles today with with the IT, so that also doesn't want to work. So let's then get this at least. So again, sorry for this. Can you still see my screen even though it is a bit smaller now? Okay, thanks. Okay, so let me show you what we want to do with these questions of a chain rule. And let's just do that first one. Okay, so what we need to do with a chain rule is, and what is important nearly, I also want to just show you how I normally look at this so that you can get a bit of a clearer and easier way to work these things out, is that, so we now have this function of y is equal to 2x plus 3 to the power of 5. Okay, so what we're going to do in this instance is to say, okay, but let's look at this function. We're going to call it something different. What you will see in most of these examples is we will call it u, and if there's more, we call the second one v. So it's just to move away from a traditional x and y, we'll call it u. So what we will need to do when it comes to the chain rule is we will need to differentiate basically the one function of u. So we will differentiate that, and then we will differentiate the other function that was created, that is still around x. Okay, so how again we can look at this is to say we will need to differentiate the u function, and then we will differentiate whatever that x is to the power of 5. So we've now created that u. So u to the power of 5 we will need to differentiate. So we will differentiate whatever within the brackets. So we will need to differentiate 2x plus 3. So that we will need to differentiate. And then what we will need to do is to say we will need to differentiate u to the power of 5. Okay, so that's the two things that we will differentiate. So if we differentiate the first one, now remember we're working with a chain rule, but what is cool about this is to differentiate this one, we still use the normal power rule. So 2x plus 3, it becomes 2. Remember that is x to the power of 1, x to the power of 1. When we differentiate, that becomes x to the power of 0. So if we differentiate 2x plus 3, it becomes 2. And then we differentiate this, again, the same with the power rule. Okay, so that is then our answer. But so can have it as VAT. But remember, we said U is equal to 2x plus 3. So all that we still need to do is replace U in this function. So the rest we keep the same. So all that we do is say 2x plus 3 to the power of 4. And that will be how we use the chain rule. So let's quickly go back. I don't think they actually show it. No, they actually don't show it. But that is how you would have calculated it. There is now a few other examples that we will go through. I was hoping that they actually, here it was. Okay, so 2x plus 3 to the power of 5. So what we've done is we've looked at the 2x plus 3. We've said, well, that is equal to U. And then we would differentiate that. So it will become like we also calculated 5 to the power, or 5 to the power of 4. And then when we differentiate the 2x plus 3, it becomes the 2, like we had there. Your final answer then is 10 to the power of, or 10u to the power of 4, and then we can substitute the u by the 2x plus 3. Okay, so that is going to be nearly how all of these will work when we work with the chain rule. Okay, so again, let's look at this one. The function was e to the power of 4x plus 5. So let's follow now some principles of when we work with e. So e to the power of 4x plus 5. Okay, so let's again say 4x plus 5 is equal to u. So then we have e to the power of u. So remember, when we needed to differentiate that, it basically stayed the same. And then we need to differentiate this part. So if we differentiate that part, 4x plus 5 basically will end up being 4. So now this actually looks quite easy. But remember, we will need to simplify it. I wonder if I'm missing something here, because that seems way too easy. Okay, 4e to the power of 4x plus 5. So what made this nice is because when we differentiate, and that's why it's so important when we looked at the e function and the ln function, when we differentiate, if we needed to differentiate that, sure, it would have been quite difficult. But because we make it simpler, much more easier to differentiate. I probably would have made some weird mistakes in there if I needed to differentiate that without using the chain rule. So the chain rule actually makes it, in this instance, very easy to differentiate, because if you can see, it was basically differentiate that one, differentiate the u, very simple in this instance. Okay, so that was the chain rule that we used. The third rule that we're working with is your product rule. Okay, so what the product rule will do is that for the product rule, we will look at, and we'll get to an example now as well. But if I look at that, so let's say that was my function, the one function was ux, the other one was vx, and how I always look at this, and what is nice about the product rule, there's no do this one first, do this step second, or anything. So what the product rule entail is, just say this was, we'll get to an example now, is that you say the one, if it was ux, it still stays ux, but you multiply it with the differentiation of vx plus the differentiation of ux times vx. So if you have two functions and the one was, let's make something up, the one was, let's say that's your two functions. So in this one, we will keep it as 3x. In this one, we would have differentiated 3x, so that would have become 3. If your second function, let's make that simpler, just to show how we're going to use it. So the second function, then, okay, differentiate that. So if it was x minus 2, if we needed to differentiate, it would only happen to the x, so x differentiated would be 1. But then here we would have said 3 times, and we would have kept the second function. Okay, so 3x plus whatever now is would have been your final answer. What I like about this is, so if you did that part first and then this part, it wouldn't have mattered. You will get exactly the same answer. So with a product rule, there's no nearly ways to say we must do this one first and then we do the other one second. It's basically the one function times the differentiation of the other function plus differentiation of that first function multiply the second function. If you do it other way around, to say, I take the second function, I multiply it by the differentiation of the first one, doesn't matter. Okay, because then you're just doing the second part first, and that would not have an impact on your answer. Okay, so where we will use something like this is when we have something where we have two functions. It might be that your second function was now not the nice one of the 2x, but it basically has something to do with e. So again, let's work that out for you guys. So if it was something, let's put in a new slide. So let's say it was EX x to the power of 2 plus 5. Okay, so we use product rule. And we just first write it out before we do anything. So it's the first one times differentiation of a second one. The differentiation here would have probably given me something like that. Plus differentiation of the first one, which is exactly the same because EX differentiated stays EX times the second one. Okay, and then I don't know if I wanted you to multiply it out, or if you, so what Fabian just did is say, okay, well, there's the EX, there's the EX, so you can take that out and put it in front, and then what is left is x to the power of 2 plus 2x plus 5. Okay, so let's look at e to the power of x taken out, x to the power of 2, so they didn't even write it in that order, but I always like to write it in the correct order, but it is exactly the same. So it doesn't matter how you write it. If you write it that way or if you write it this way, it is exactly the same. So that is the product rule. So again, when you look at the product rule in, where was it now? In the formula, it looks very daunting, but in simple terms, you look at it nearly and say, well, and here you can look at it, differentiation of a one times the other plus the other times the differentiation. So you just follow that principle, and it's been easy to use. Okay, so you'll see now there's a few ones here as well. Again, I'll share and you can try it a bit. I think it is in your study guide as well. And then I will share another assignment with you that you can study a bit more. Okay, the last rule that we need to work with is the quotient rule. So the quotient rule looks at when you have a function divided by another function. So it's not when we have 4x plus 4 divided by 4, or that one that we had earlier where we had 2x minus 2 or something like that divided by x. Okay, because here you can still divide certain things into one another. So the quotient rule is not when we look at functions like this. What the quotient rule, because, and let's give you a reason why, is that you can simplify this still. And you can simplify it so that you can rather use the power rule than the quotient rule. But if I give you the following functions, So if I said to you, okay, 4ex divided by 2x to the power of 2, I would have said, okay, flip. I really don't know. You can say, well, 2 goes into 2 once, 2 goes into 4 twice. Okay, but now I don't know what to do next. Okay, so then you use the quotient rule, because again, you can't use the power rule. You can't use the chain rule because it's not something multiplied by something. The only thing you can basically do is to say, okay, we need to use the quotient rule. Okay, quotient rule, here you need to at least keep a bit of structure. Chain rule, we didn't need to, but here you need a bit of structure. So what we need to do here is to say, and you can call it again UX and VX if you want to, but basically what we're going to do is to say, well, you need to differentiate the top one. So in this instance, it would have stayed the same. Differentiate that times the bottom one. So you'll see it's nearly the same as your product rule. Differentiate the one times the other one. But then what happens is we need to say, okay, well, minus your top one, differentiate the bottom one. So x to the power of 2 would have been 2x. And then we need to divide that by the bottom one square. Okay, so it is a bit different to what we are used to. So let's just again go through the principle. So it is differentiation of the top one times the bottom minus the top one differentiate by the bottom. And that you need to divide by the bottom one square. So very much, the top is very much similar to your product or your chain rule. The sign just needs to change. But then important, divide by your bottom one square. Okay, so that is where the extra thing comes in that we need to remember. Okay, so let's do one like that. I think there is my lovely example of a E, so that one you can also do, but let me quickly show you this example. Let's insert a new slide. And I think what is important for you guys when you now do the assignment is that they're not going to say to you, use this rule or use that rule. You will need to figure that out for yourself in the process. So if you see something like this, you automatically need to say, okay, sure, there's no ways I can simplify this to use any of the easier rules. So there's no ways, because at the top I've got 3 terms, at the bottom I've got 2 terms. but there's no ways I can do this with any of the other rules. So then, unfortunately, need to use a quotient rule. Okay, quotient rule says differentiate the top one. So that becomes 2x. And every time you guys will see also that we use the other rules now within this. So we're now using that power rule within this to actually work out the simpler um, differentiations. Okay, so with this one, differentiate top one times the bottom one minus the top one, and we need to differentiate the bottom one. So 3x becomes 3. And that we will need to divide then by the bottom one to the power of 2. Okay, so I would first, let's multiply the top out with one another. Maybe we can simplify something. So now we go back to first part of algebra. So 2x times 3x gives you 6x to the power of 2. 2x times 2 gives you 4x. 2 times 3x gives you 6x. Okay, that is plus 4. Here we're going to multiply by 3 and then subtract. So minus 3x squared minus 3 times that is minus 6x minus 3. Okay, and then hopefully that we will be able. So I'm first going to try to simplify that. The 6x minus 3x is 3x to the power of 2 is plus 4 plus 6, so that's 10x. Minus 6x is plus 4x. Then we have plus 4 minus 3, which is plus 1. Okay. And then we needed to divide by the 3x plus 2 to the power of 2. So what you now can see is, where was that? So there we had the 3x plus 4x plus 1 divided by 3x plus 2. So again, in this instance, there wasn't a way to simplify anything. It was just that as final answer. Okay, again, I would, before I even try to simplify this, I would now have gone to your answer set and nearly check in your answer set if that is one of the answers or if I actually need to simplify. Okay, so I would have gone now to my answer set, and because I now don't really want to start working this out, trying to simplify, and then there isn't nearly a way to simplify. So at this point, I would have once again gone to your answer set and check, okay, is there actually one of the answers is what you're looking for, before we even go into trying to simplify it. Okay, so that is your quotient rule. So basically, I just want to quickly run through this again. So first rule is your power rule, and that's the simplest one that you're going to work with. You're going to use your power rule also in a lot of the other rules, just because you will have functions that you need to simplify. Okay, so the first rule is your power rule. Then we get to logs and exponential, but that is not specific rules. It is just showing you how you're going to work with it. So the exponential and log one, I think what's important to remember here is what happens with it, because they're not really going to ask you something like this to work out this in the exam or in the assignments. They will use it in one of the other rules, so that you nearly know what the thing is that you're looking at, but in conjunction with another rule. So the second one that follows up from the power rule is the chain rule. Then the third one is your product rule. And then the fourth one that is important is your quotient rule. In your let's first go to the assignment. You probably will get one of each to work out. But when we get to the exam, there will be one or two. So, and there won't be just a product and quotient. It will be nearly one of the first two and one of the second two nearly. Okay, so that is differentiation with a rules wheel. Next week we'll go into the economic side of it when we look at marginal rules. Marginal cost, marginal revenue, those kind of things. So before I quickly do a bit of chapter 4, is there questions around this? Does it at least help a bit more? Does it make sense now? Is it a bit better? So is it at least, will it help you now with the assignment that you still need to do? And is there other questions?
Ajit, sorry to be
Yes,
informed again. I'm okay. All right. I will read. When would you be able to post this video again?
I'll download it now, and even within the next half hour, hopefully, I will
Okay.
download it and put it onto our WhatsApp chat.
All right. Okay. I think all right. I'm just gonna send you a WhatsApp so that at least yeah,
Perfect.
yeah, because I'm going to redo this again probably in the evening after I've done with MNB as well. Yeah.
Oh, you
From what
guys have that as well still to do. Oh, good luck.
Yeah, I've got MNB, which is one of the assignments that's due on Monday, but I'm all right with it.
Okay.
Yeah.
Cool.
All right. Perfect. Thanks.
Thanks.
Sure.
Okay, so let me quickly check that. Where is, because I just want to make sure now that I save this. And that it's there. Okay, cool. Okay, so we've got a few minutes still, so let's do a bit of chapter 4 as well. Nearly what chapter 4 was about was the application of nonlinear, which we did in chapter 3. So I'm just want to do a bit of it so that if there is of these questions included in your assignment, that you have at least that sorted out as well. What we don't do today, we'll catch up on in next week in any case. Okay, so what we gonna look at in this chapter is, so in chapter 2 we looked at the quadratic functions. In chapter, or the simple line functions in chapter 3, we looked at the quadratic functions. So what chapter 4 is about is nearly taking that quadratic equations, the simple line equations, and adding a bit of economics to it. So things that now suddenly we'll look at is revenue, cost, profit, how you work out total revenue, total cost. When we look at the break-even point for not simple lines, but quadratic equations. So that is nearly what we're going to look at. So what you will also remember is in the first assignment, we nearly looked at we have a demand and supply curves, but we also looked at total cost. That was a function of your variable cost plus fixed cost. And then we also looked at your total revenue, which was your price times Q. So in here, your total cost would have been, that fixed cost would have been, and let's just use a function or a placeholder that's normally something like C, and your fixed cost would have been a price times a quantity, but not the same price. So let's just make it P1 or something like that, and P2. So it would have been something like that, and then your profit function would have been when we subtract the two from one another. Okay, so that is where you will now, when we get the information, you will see that your total revenue function now is actually hyperbole. So it is a nonlinear function. Here you can see, if we look at that function, it has a max point, it goes down, but that is now your total revenue function, and it's not at all a straight line, because it has something q to the power of 2. Your total cost function looks a bit different, and here we are actually having so what is it as a cubic function, and by that standard, then instead of having the quadratic, what happens is there's another shape in it. So you can see here, there was the first bend, and there's the second bend. I just made it a bit clearer in mind. So not just one bend, it has two bends. Okay, and again, depending on how the curve it is, it can be, this one would have been a negative in front of a if it slopes down to that one. Here it goes positive, so that is why there's a positive in front of that. What I've, and this might be a nice one, what one of my other classes said this week is how to remember what side the curve goes. So if it's negative in front of the x square, it goes down. But how you can see it as well is negative is when something is not happy. So think of it as if you're looking at the not smiley face. When it goes down, if it's positive, everybody is happy and you're smiling. So I thought that was actually quite a nice way of remembering this, the way of your curve. So it's if it's negative, everybody is unhappy, you're not smiling, so you know the arms of the curve will go down. If it's positive, everybody is smiling and your arms of the curve will go up. So that's just a nice way of actually remembering it. Okay, so let's see if there is an example. So here was an example. So and I think we can end off a session today with this one. So it says to us the firm's total cost function is given as total cost is 4 plus 8q minus q to the power of 2. And the total revenue function, where X is the number of units produced and sold in thousands. How many units should be produced to maximize profit? Okay, so what we will basically do is say, where are these two equal? And then hopefully we will solve the answer. Okay, so here we have q to the power of 2. So I want to make that positive, so I'll take it over to that side. Then it becomes 3q to the power of 2. The 50, so I'll take everything now to this side, so it becomes minus 50, so it becomes minus 42q. And then, okay, there's nothing else, plus 4. Okay, so that now is your function. So your total cost minus total revenue. So remember, that is actually your profit function. And obviously, if total revenue is more, so here we just, when we moved it, so it's also your total revenue minus total cost. Okay, so again, it doesn't really matter, because what the answer will be, we can work that out. Okay, so we've done that step now. So now they ask us how many units sold to produce the maximum or to maximize profit. Okay, so what do we now need to do to maximize profit? So remember, so this slope, if we look at this function, it will go up. So, okay, it would probably have gone, if I look at this function, where it would have been. So this actually, if I now look at this, is a combination of two things. It's a combination of what you've done in chapter 2, 3, 4 is now this, so it's application, but what we're actually also doing here is we're working out what is the straight line to that function where it's going to maximize. When we work out that straight function, we are actually differentiating. So now you can see this question is actually going to come in the session that we do next week, because this is, yes, it's application of study unit 3 plus study unit 5. Okay, and when you started off the question, it never looked like that is actually where it's heading. And that's again why I probably had it in here at the beginning, is because we're looking at everything we're talking about in study unit 3, total cost, total revenue, but then we need to maximize it. So what we need to do is differentiate this formula. So when we differentiate this formula, we get 2 times 3 is 6q. That becomes minus 42. That is equal to 0. So then on this side, we've got 6q. On this other side, we've got 42. We divide by 6, so q is equal to 7. Okay, so all of us would have said, oh, cool, there is my answer. But again, a trick, because here they tell us Q is the number of units produced and sold in thousands. So sold in thousands, must multiply that by 1,000. So the final answer is actually option 3, which is 7,000. So what is important in this question is, and that's why I wanted to show you guys this as well, because that is, in a sense, how a lot of your questions is going to be in the exam, is that there are going to be links between the different sections. And this one is definitely a proper link between study unit 3, study unit 5, and then you need to know the application of that. Okay, so that is, I think, what is important when, yeah, we can do the math emojis as well, Visa. But that is why I think it's important that as you go through the study units, one doesn't always see the relevant links between the different study units. And I think that is what we will do throughout this sessions that we're having. I'll try to at least bring 1 or 2 of those questions in where suddenly you see, okay, but I would never have thought that study unit 3 and 4 would actually be able to go all the way that you needed to differentiation in it, because you nearly look at study unit 3 and 4 total cost, total revenue. How do I get to differentiation with it? But here is a clear example of how to do it. There would have been another way. So what is that one function? So remember there was that minus b over 2a that we said one can also use to find the turning point or where you would maximize. So if you look at using this, we would have said minus b, so it would have been 42 divided by 2 times 3. So 42 divided by 6 would have given you 7. So that would have been another way without differentiation to do it. But that would have also been, that is where the turning point is, where you would maximize it, which is actually the same what we're doing here. So one would not have known that yet until we have gotten to differentiation. So yeah, so that's just what I wanted to show you guys, is nearly the link between the two, but we will go into more detail in some of the other sessions on that as well. Okay, great. Have a good afternoon, or yeah, rest of the morning, about an hour left of the morning, and good afternoon and weekend. And we will chat again next week, the same time, 9 o'clock next Saturday morning. Okay, great, everyone. Let me stop sharing, stop the recording so that you guys, I can share it later on with you